Hello. Just 1 second.
Um,
Hello. YouTube's working. LinkedIn's working. Okay, perfect. Hello, everybody. How's it going? How are you guys today? Um, Today we're going to be building a load balancer in Go. Um, I'll explain what a load balancer is in a little bit, but basically it's a project I've been working for like a while now. I was doing like an HTTP server implementation in Go through like a course from a content creator I follow. And so then I extended it to like work on some other like system infrastructure stuff. And once again, I'll explain if this is a bunch of like mumbo jumbo to you. I'll explain a little bit more later in a second. But yeah, that is what we'll be doing. The project, unfortunately, like I mentioned, I've worked on it already for a little bit, so it's not gonna be new. Like we're not gonna start it from scratch. But I do want to start other projects from scratch once we're done with this one. Um, but we'll be working on a couple features. I'll probably okay. Maybe I'll start off with like something else just to warm up, and then we'll get into it. I'll explain what a load balancer is, what it does, and then we can like get right into it. If you can see today, I changed the background. So like last time I was streaming from the International Space Station. Today I'm streaming from Tatooine. I'm gonna try and keep things interesting, change the background of every stream, maybe, if I remember. But today we're streaming from Tatooine. Okay, so as we did with last stream, and like I mentioned, I wanted to do this. Let me not leak my Gmail. As I mentioned, I wanted to do this was to like start sort of like a series type thing. So what I'm gonna be doing is doing the Lorcana card of the day. So before, like last stream, what I had it set up is like we pick a random number from 1 to 11 because there are 11 sets of Lorcana, and then we pick a random card from that set. After that stream, I started building a tool to do it instead. So I'll show you guys the code, but actually it's pretty cool. I built it in like, I don't know, 50 minutes. It was not too complicated. I did in C++. I'll show you the code in a second. But it's basically a tool that like pulls up the Lorcana card of the day automatically for us. So it's right here if you see it in my status bar, and let's see what the card of the day is. Ooh, okay, Tigger. This is a new card. This is from the new set of Winterspell. It's very good. I pulled like one of them in a pack I had recently. I might have like a copy, maybe. We'll see. What it basically does, so it's a purple card, and I'm a purple steel player. So for those of you who don't know, in Lorcana, you're allowed to have 2 colors of cards on your deck, and so I play purple and steel, but there's also like amber, which is yellow, sapphire, which is blue. There's ruby, which is red, emerald, which is green, and so you have all these different colors. And so they do different things, each of them like specialize on things. For example, purple specializes on bouncing characters or like drawing cards. I don't think it's probably like I probably put it somewhere else, so I don't have it with me right now. I am gonna share with you a card that I pulled recently. I thought it was pretty cool. I went to like my local game store to play this weekend, and I opened a couple packs, and I pulled this. Oh, there's a little bit of glare. It's a genie card. Maybe I'll actually reverse my camera so you can read it. 1 second. Or flip horizontal. There you go. So it's a genie card. I might pull it on just on the desktop instead. But it's an epic, so it's like a special rarity card. It's got a pretty cool design. I wish you could like see it better on the camera, but it's like it has like foil and everything. It's pretty cool. And I have the non-foil version as well, which is just, this is what it looks like. So I'll pull them like side by side. There you go. So yeah, this one's like this one's like silver, whereas this one's just like the regular color. It's a pretty good card. I'll pull it up on the desktop first, but let's talk about the Lorcana card of the day, which is the one I have pulled on my desktop right here. Right here. It's Tigger, Bouncing All the Way. So it's from Winnie the Pooh, which I've been told many times. I pronounce it like Winnie Pooh, and I've been told many times I'm wrong, and it's actually Winnie the Pooh, so I'm gonna say Winnie the Pooh instead. And what this card does, so I'll help you like read through it. It's a 4-cost card. It's inkable, so ink is your resources in the game, so you can use the cards that you have in your hand to like play them or to add to your resource pool. It's got the stats, so like it's got 4 strength and 3 willpower. This is the attack and this is the defense, basically, if you know from other card games. It's called Tigger, Bouncing All the Way. It's a Storyborn and Tigger classification. This is relevant. I mean, it's really funny that like Tigger has its own classification, like he's a Tigger. If you've ever watched Winnie the Pooh, I think it's pretty funny. And it says, when you play this character, you may return chosen character, item, or location with cost 2 or less to their player's hand. So this is what we call a bounce effect. And bounce effects are pretty good because there are some cards that, for example, allow you to draw when you play them. And so sometimes you want to bounce those cards to be able to draw again. There's this, actually let me pull up Dreamborn. There's this very popular card. I actually run 4 of them on my deck. It's called Doc Bold Knight. This one. It says when you play this card, you may discard your hand to draw 2 cards. So it's a very good card because if you only have this in your hand, when you play it, you have 0 cards in your hand and you draw 2. So you basically it's like a +1 advantage. You put 1 card down, so that's -1, and then +2, that's a +1 advantage. So it's pretty good to be able to play this like repeatedly. And this Tigger, the card of the day, helps you like bounce the card to your hand to be able to play it again. But it's not only good for that, but also because it doesn't restrict you to only return your chosen characters, but you can return characters, locations, or items with cost 2 or less to their player's hand. So most of the cards that you bounce, you can only like return them to your hand, but with this card you can return your opponent's cards to their hand, and that like helps with your tempo in the game. So there's this other card called what is it, Grandma? Oh, I forget. It's not Grandma Tala. Let's see. Let me actually pull it. So it's set. It's from Whispers in the Well, maybe? Or Winter Spell. It's one of the two. And it's an Amber card. And it has an epic, so let's actually look up the epics. Oh, Grandmother Willow. So this card. What it does is once during your play, you pay 1 less for the next character you play this turn. So it's very good because it allows you to play characters for one resource less. So you can pull very powerful characters very early. So one good thing you can do with Tigger is you bounce their Grandmother Willow to their hand. So you return it to their hand, and that ruins the tempo of the other player because then they have to play it again on their next turn. And so they have to waste more ink to play it, whereas before they could just like every turn just keep paying 1 less. So that before they would to be able to like add a lot of tempo to their plays, be able to play a lot of characters very early, this kind of like slows them down to not be able to do that. So Tigger's also good for that, and you can bounce characters, items, or locations. So if they have a really powerful item, you can bounce it to your hand, and that also helps with tempo. So it's very flexible because you can do it for your opponent and for yourself, and it's pretty good in purple. I used it for a little bit. I wish I only have one that I've like gotten from a pack, but it's really good. So yeah, that was the Lorcana card of the day. And actually, if you saw like here, like I had the Lorcana card. It's an executable. that pulls up like a random Lorcana card, and that's what we're gonna use for the Lorcana card of the day on the streams. And I'll show you the code for it. So if we do Lorcana card of the day, okay. So this is it. That's why I said it didn't take me a lot of time. I just had to figure out how to like open a website on your browser using C++. And then the other challenging part was each set has a different amount of cards. So the first, okay, so basically the program runs in this way. So you pick a random number from 1 to 11, and that's your set. We have 11 sets, so we pick a set at random. After you pick a random number from 1 to 11, you have to pick a random card from that set. And so the problem is, every set, or like most sets, have different amount of cards. So you can't just pick a random number from like 1 to 250, because some, as you can see here, some sets have 216 cards, some sets have 223, some sets have 225. And so you have to pull a different range of random numbers for the number of the card, depending on the set. So I'm going to explain through here. So we first create like a reference hash map, and then we store the amount of cards per set. So for set 1, there's 216 cards. For set 2, there's also 216 cards. For set 3, there's 223, and so on and so forth. Then we create strings for the set and card number, and we initialize our random number generator from 1 to 11 to pick the set. We generate the set, and we pad it with zeros to the left so that it's in this format, basically. So you generate a number from 1 to 11, and then you add a 0 to the left and becomes a string. Because you want it in this format. And then you look up what number of cards there is for that set, and you generate actually it's 1 second, card number in, card number distribution. Okay, so yeah, so right here you create another random number generator from 1 to the number of cards from that specific set. So we check the reference table, and we check the amount of cards for that specific set. And then we seed the random number generator, we generate the number of the card, and we pad it with zeros to the left. And then we grab the asset from this specific link. So it's CDN, it's like a cloud, what is it? CloudFront? No. Cloudflare. It's a Cloudflare bucket. And here, so this is the link, and then the cards will be stored in this format. So like the set would go here, and then the card number would go here. And then it puts in the random numbers that it generated, and then it shows the URL on your browser. Pretty simple, but I thought it was pretty cool. I wanted to do some way to like do it really fast. What's up, Sean? How's it going? How are you doing, man? I'm glad you were able to make it. What time is it over there? It's probably like 11. Yeah. I was just showing. I created this. So I play a trading card game called Lorcana. It's similar to like Yu-Gi-Oh, Magic, and all that sort of stuff. And so one thing I'm doing for streams is every stream I'll pull up a random Lorcana card. And so before, like last stream, I didn't have anything set up, so I just basically generated a random number and I pulled the card from there. But I created a program like yesterday to like pull it automatically using C++. So that's that right here. Yeah. So this was our Lorcana card of the day. Okay. Awesome. Now that we've done that, I think we can jump into load balancing. Did you start? It's like 11:15. Yeah, I just started. I started at like 6 sharp, pretty much. Okay, so like I mentioned, today we're gonna work on a load balancer. And I'm gonna try to explain what a load balancer is from scratch, because there's some people that are not aware with what it is and how important it is for like web traffic. So let me draw a model for you. So when you try to access a web page on the internet, this is your computer, right? And so let's say you're trying to go into Instagram. And so Instagram servers are right here. That's a very bad Instagram logo, but whatever. Yeah, I'm calling. So it's a for the Lorcana card of the day. It's a Cloudflare bucket that they use for like some other service, and I'm just using that to get the images, but and then just generating random numbers for the card. So this is Instagram, right? And so when you're accessing Instagram, we're saying that you're accessing from your computer. So Instagram servers are right here, and so your computer sends a request to Instagram for your profile, for example. Let's say you're accessing your profile, and then Instagram returns your profile from like their servers, and that's called the client server model. That's called the client server model, and it's what like the internet is based out of. So for like small apps, let's say you're creating a small app, you can normally serve your users because you're gonna have probably like 0 users, maybe 10. And so you can serve them off of one machine. One computer can help all of your clients get what they need. But with Instagram and with a lot of like big businesses, they have a lot of clients, like a lot of people trying to request their profile. So here, I'm probably just gonna draw like 3 of them, but you're gonna have like millions of people trying to access their profiles on Instagram, right? And so if you only have one server to serve millions of people, your server's gonna get overwhelmed, and it's gonna be your app is gonna be very slow because it's only gonna be able to like serve one user at a time. It's able to do it very fast, but as your number of users scales, then it's gonna be very, very slow for the app to actually like serve your users. So what do you do at that point? So you have 2 options. You can scale your server vertically. What that means is you get a faster computer, basically. So you get a better CPU, you get a better GPU, better RAM, and so it's able to serve more users in the same amount of time because it's faster at returning your profile on Instagram in this case. The other option you have is to scale horizontally. So what that means is Instagram will have multiple servers to serve their users, right? So you have, this is server 1, server 2, server 3, and this is good for a number of ways. One of them is, like I mentioned, you're able to serve like multiple users, like more users if you have more machines. It's also good for like serving users that are really far away. So if your app serves like the whole world, you are gonna have to serve people in America, in Europe, in Africa, in Asia. And so you want your server to be very close to them so that the response time from when you ask for your profile and you return it back is really short. So you're gonna wanna have servers in different geographic locations. And so it's good to scale horizontally for a number of ways. You can scale vertically, but that reaches a limit and it's not very scalable. It's better to scale horizontally and have multiple servers. That's why people have like big companies have data centers to serve all of their different users, right? And so when you get to this point and you have multiple servers to serve your users, you have a problem, and it's which server should actually respond to the requests from my clients. So, hey Alice. So here, like, how do you know, or how do you figure out that, like, when this specific client right here requests something from Instagram, which of the 3 servers should actually respond to that request? I'm doing good, Ellis. How are you? So which of the 3 servers should respond to that request, right? And so at that point, you can do a couple of things. So for example, you could do it per region, like we mentioned before. So the server in America serves users in America. The server in Europe serves users in Europe. And that's a way you can do it, but you sometimes want to be more flexible with the way you serve your users. So for example, if you have multiple servers for America, you want to send your traffic, or send the people that are requesting their profiles, you want to send them to the server that is least overwhelmed. Because let's say this server 1 is receiving a lot of requests, right? Then you don't want to send more requests to it because it's going to keep getting overwhelmed. you want to send them to, let's say, server 2 that is more free. It's only like 0 requests, so now you can actually like serve more users. You want to send it to the one that's least overwhelmed. And that's where a load balancer comes in. So that's where I was going with all of this. So what you do to fix that is you put this, let's say, device in between. So we're going to call it LB. You put this device in between that is going to figure out which server should serve each of your clients, right? So, like I said, you can do it geographically. So you can tell this load balancer, okay, when you receive traffic from America, send it to the America server. When you receive server from Europe, send it to the Europe server, and so on and so forth. This load balancer can also like serve depending on traffic. So when you receive traffic, send it to the one that's managing the least connections, or the one that's using the least resources, so the one that's more free. Or you could do it, sometimes you have a web page and you're doing A/B testing. So for those of you in marketing that do A/B testing, you want to serve 2 different versions of your app or your web page to a person or to your clients, and so the load balancer will be able to figure out, okay, which clients should receive the A version and which clients should receive the B version, right? And so that's why this load balancer right here is so powerful. So its job, it's like a traffic conductor, where it's trying to figure out where to send the traffic to your app or your web page, so that your app is serves your users the fastest, or it's flexible so that you serve them in some specific way you want. And that's what we're going to be building today. So if you can tell, like I mentioned, there's multiple methods to serve your users, and so there's multiple algorithms you can use to be able to tell where the traffic should be sent. One of them is called, the simplest one is called round robin. And what round robin does is basically it sends them in order. So you receive one request, you send it to server 1. Receive a second request, send it to server 2. Receive a third request, send it to server 3. And then let's say you receive another request and you only have 3 servers, then you send it back to server 1 and you keep cycling, right? Then there's another algorithm. There's weighted round robin. So let's say, like I mentioned earlier, you scale one of your servers horizontally. So this server right here is very beefed up. It's like so much better than the other ones. So you're going to want to serve more traffic to the server than the other ones, because it's going to be able to handle more traffic. So instead of sending the same amount of traffic to each, like in round robin, you do a weighted round robin where you say, I want to give more importance to, I want to receive 5 times as many requests as the other servers for this server. So the way it would work in that case is you receive a request here, it goes to here. You receive a request here, it goes to here. You receive another request, it also goes to here. So you're going to serve this 5 times in a row before serving the next one. Because it's 5 times as more important, it should receive 5 times as more requests, right? Actually, it would be 5 out of 7, because this is weight 1, this is weight 1, so you receive 5 out of 7 requests. So that's weighted round robin. Another algorithm you can use, and let me actually just make this a little bit more manageable. Another thing you can use is like a resource base. So these are called dynamic algorithms, where you're not only doing it like based on a static table like we mentioned before, like you have like the weights in the weighted round robin, and that's static, like it never changes. You can have a dynamic approach where it changes depending on some information you provide the load balancer at a point in time. So let's say here we can do what's called a resource-based load balancer, where it checks how many resources are being used in this machine. So let's say you're using 15% of the CPU, this one's using 20%, and this one's using 50%. So you're gonna send it with the one that's using the least amount of resources. At what scale are we designing this mock system for? Is this just general? I had asked a lot of questions to AI before the initial calculation for what type of info you need a load balancer. So this, like your algorithm, or like the algorithm we're gonna build today, it should be able to serve any amount of servers, right? You're gonna come to problems with scale, and like the scaling is definitely like a hard problem. There's multiple ways to approach it, but the algorithm should be able to serve any amount of servers. Like you could have like a Kubernetes like cluster with like multiple like Docker instances, and it should be able to serve all of them. Because what the problem of scale is not a problem of like the algorithm or the load balancer itself. It's a problem of how many servers you have available to serve your traffic. And actually, you would come to like a scaling problem with the load balancers themselves, because like if you only have one load balancer to serve your app, maybe you overwhelm that load balancer, and then you would need like two load balancers. So like scaling is like a whole different problem. But the algorithm should be able to serve like a large amount of users the way we're building them. So there's resource-based and connection-based algorithms for serving dynamic algorithms for load balancing. And connection-based is very similar to resource-based, where instead of like the CPU usage, you count the amount of connections that are active in each specific server, and you send it to the one with the least connections. So let's say this server is currently serving 5 users, this server is currently serving 10, and this server is serving 100. You send it to the one that has 5. And so that's also dynamic. Instead of using CPU percentages, we're using amount of connections. And I wanted to mention that because that's what we're going to be building today. So the load balance, like I mentioned at the beginning, I've already worked on this load balancer for a while. So I've already built something that works with round robin, with round robin and with weighted round robin. But today what I would like to do is build this resource-based algorithm and connection-based algorithm. And I'll show you a little bit of the implementation of the code, because I've already established some of the groundwork for this one. So what do you need for a resource base? You need the CPU percentages. So that's one of the things that we needed to work in the project, which was how do we get the CPU percentages from our servers? And so I've already built that. I'll show the code in a second. And the least connections, we're also going to have to store how many connections the current server is actually handling at the moment. Okay, so with that explanation, I think I can jump a little bit into the project. Okay, so let me jump into my Linux environment, and then personal go cd load balancer. Okay, so this is our Go project. And for those of you who don't know, Go is a programming language created by Google. It's actually like I've started trying it out very recently, and I really like it just because it's a very fast programming language, but it's also, you don't have to write a lot of boilerplate code. It's very easy to write, and you don't have to write a lot of code to do the same amount. Whereas with like C or C++, it is really fast, but you have to write a lot of code to be able to implement something, and there's not a lot of libraries to support it. Is there a preferred way or a standard way, or do you just pick based on trade-offs? It depends on what you want to do. If you want to serve like to the servers that are least, like if you're worried about your app being really fast, then you wouldn't want to use like least connections or resource-based. But you could, like, if you're worried about like A/B testing, you would have a different algorithm for that. Or if you're worried about geographical location, you would have a different algorithm for that. So it depends on what you're trying to do. I would say that most apps are worried about like efficiency and being able to serve as many users as possible. So they would use either resource-based or least connections, which is why I wanted to focus on that. Okay, so this is our Go app. So it's divided into CMD and PKG. So CMD, I have here just like a testing environment for our load balancer and our servers. For our servers, I created a Docker file that runs this server right here. And this server, it basically sets up an HTTP server that can receive requests. and it has some specific routes that we need to be able to use with the load balancer. So like I mentioned before, we want to be able to get the amount of resources that the current CPU, the amount of CPU utilization for the current server. So that's one of the routes that that is in here. It's called I think /status. Yeah, so right here, we're handling a route called status, and so when you request the route status, it's getting the CPU utilization for the server and returning it to the load balancer to keep for its algorithm. So I think that's one of the constant, like it's just like it has this, you need to have this route in the servers in the way I've implemented it, because it's able to get the CPU usage. And if you get any other server requests, it just responds with I think it's just like a generic page. Yeah, I think it just returns a 200. Everyone, any of them chat? I'm still stuck on VS Code. Yeah, I picked up NeoVim, like I'd say like a couple of years ago. It's okay, so I wouldn't recommend it for everybody. It's definitely like if you just want to like code and you want things to work, sticking VS Code is perfect. I would recommend to everybody to learn Vim Motions. Vim Motions have made me like 100 times more productive to be able to like edit code like really easily and without like having to use my mouse to like move around. Like I can move around my file like this and like look up like main, for example. And so it's really fast to move around the file. So I recommend everybody use Vim Motions in your own editor. So you can add Vim Motions through like a plugin to VS Code. And so go for that if you can, because it does make you a lot more productive. The reason why I switched to NeoVim from like VS Code, which was what I was using before, is because I used to program on my laptop. And at the beginning when you're using VS Code and you have no extensions, it works perfectly. It's really fast, but then you start adding extensions to your VS Code and it starts just getting really, really, really slow. So I like from NeoVim that it's very lightweight. Another thing is you can set up like custom commands to like edit code. And like I have like a lot of keybinds that are not in the Vim Motions that you could use in VS Code that are customized to myself, and I can add a lot of like functionality to it. So that's why I like it and I've stuck with it. But yeah, it's a lot of like setup. I mean, you can pick like a distro to like make it easier for yourself, like something that's already done for you, sort of like when you pick a distro for Linux. But I wanted to like build my custom one. Actually, I have my files up on my GitHub. This is my config file. It's very long, as you can see. But like for example, here I have some keybinds set up. This is for example to run Python code. I just do like space R, and it runs my Python code, and it shows me the output at the bottom on the status bar. Instead of having to like exit the file and then Python whatever. My VS Code was taking 4.4 gigabytes yesterday. Yikes! I was trying to find out what code helper was on Mac. It was cooked. Bro uses NeoVim, cracked. Electronas app. Yeah, I use NeoVim, by the way. I don't touch grass. Yeah, I don't. I have my I have my things that I don't like with VS Code, but it's good software. Like it works for like 90% of people, so I understand why. Okay. So let's go back into the load balancer. So like I said, I have this like file to like serve my server with like the status route and then something to like serve generically. And then I have a Docker file to be able to create instances of those really easily. Then I have my load balancer right here, which is really, really simple. It just creates a load balancer. It creates 3 servers and it connects them to the load balancer. And so this is what I can use for my testing environment. So right here, if you see load balancer make LB RR, it's just a round robin algorithm. And then I create 3 servers with an API I created to create my custom servers with Docker. And if we go back here to package, I have 4 directories. I have one for my algorithm, so I have my round robin, my weighted round robin. I have Docker, which is just basically like a utility, like library to be able to create servers and like interact with them. I have my load balancer.go, which is where I define all of the things related to my load balancer. So here I define the interface for it. I define this interface for a scheduler, so like this would be the algorithm. I create a function to like a constructor, which is this make OB function, register, remove, a handler for the load balancer. So what should it do when it receives any requests? And you basically pick your scheduler and send your request to the attached servers depending on your algorithm. So if you see here, this is like right here is where we pick the next server we should pick for like sending our traffic to. We use that scheduler that we had on our definition. We start the load balancer here on port 42069. Nice. We have a status check, and this is like the loop that checks the health of each server and returns all of their the CPU utilization. And so this is run every 5 seconds. Every 5 seconds I have like a go routine that sends a request to the server, checks what its status is. If the server, for example, doesn't respond, that server isn't healthy anymore. So we update the healthiness of that server, and we say like it's not up anymore, it's down. Don't send any request to it. Which is, where is it? New decoder. Yeah. We check health, so like this is the routine. It does the status check, and so like if we don't have any errors, we set healthy. So if we have errors, we set healthy as false. This is what I was going through. So we set the healthiness of the server as false, and we don't send any more requests to it. And then this is the go routine. Actually, it's every 20 seconds. Yeah. Okay. So it's every 20 seconds I'm doing it. I was gonna say like 5 seconds is way too little. What I'm doing with the timeout is if I send a request and it's like pending for like 5 seconds, it just says like, oh, okay, the server is not responding to me. I'm just gonna set it as like, I'm gonna send back an error and set it as unhealthy. So that's our load balancer.go. And then lastly is like the server, where we define what a server is and what things we need. So right here we have the stats. So right now I'm only using CPU utilization as the stat for my resource base. So we record CPU usage. And in our server we have implementation, we have a mutex. So you need to have a mutex here because when you're checking the healthiness of each server and updating them, you're gonna like have multiple connections at the same time. So you don't want to have like a race condition where you, like for example, where you update the stats at the same time, and from multiple, like let's say like load balancers or whatever, you update the stats at the same time, so there's a race condition and you can have like some unexpected like side effects here. And then set healthy, which just basically locks the server, sets the healthy, and then unlocks it at the end. That's what this defer is for. So one of the things we can add like right off the bat, that's gonna handle some of the things we want to do, is to this server, besides the stats and actually we can add it to the stats, and we're gonna put here connections. I'm gonna just type in the whole thing, and it's gonna say, so connections, and I'm gonna just follow my autocomplete. We get it from JSON through like a connection. So we're gonna have to update our, actually, do we want to do it this way? Let me go back to my server implementation. CMD HTTP server, not the Docker file, but here. So I just don't know if the server itself knows. Yeah, the source code is on GitHub, so it's gonna be GitHub, github.com/agentbot/go. It's a I should migrate this to like another repo. But here I have an HTTP server implementation that I did from scratch, and so the load balancer code is gonna be here in Go load balancer. So what I don't know is, does the server know how many connections it's handling at the same time? And the answer is probably no, is what I would say. So does this loop server started, and then when you handle, I mean, I could write it so that it knows, but I think what's best is for us to keep track of them in the load balancer, because the load balancer is the one that forwards the request to the server, and then when it returns it to the client. So I think it's probably best to keep track of how many connections are on the load balancer itself. So we can keep it on the stats, server.go. So we can do this, but we don't need to get it through JSON because we're not getting it through like our HTTP status route. Okay, and now we can go to the load balancer here. And so whenever, let's see, this is start. Yes, coding. Can you notice it? So if we go to the handler right here, it receives a request, it logs it out, then it picks the next server, then we get the URL for that server, we create a request for that, and we send that new request to the server, and then when we receive the response, we just send it back to the client that originally requested. So I'm gonna add a method to server. So as we have here, like set healthy, I'm gonna add one that says add, this should be a public, add connection. I don't get it. Oh my god. Okay. I was doing this drawing earlier. I guess it's kind of hard to figure out now. But basically, we're doing a load balancer, and what it does is, like, from your phone, and this is Instagram, by the way. So Instagram has multiple servers to, like, whenever you request to, like, get your profile, you ask for, like, your profile information, your pictures, your followers, all that stuff. You make a request to Instagram, and then Instagram returns your profile, right? But Instagram doesn't just have one computer that returns that information to you. It has multiple computers that are multiple computers that can return that information to you. And so you need like a piece of software in between that has to figure out which computer should it send your request to view your profile to, which computer should be serving that information to you. So that's what a load balancer is. It sits in the middle between you requesting your information to Instagram and an actual server returning that information to you. So that's what we're doing today. It's like a load balancer. So it sits in the middle and it figures out, let's say, for example, depending on your geographical location, if you're in America, it should send your request to the server from America. So you're waiting the least amount of time. Or you send the request to the server that's least overwhelmed, so the one that's handling has the most like CPU utilization, like the least CPU utilization, so that's the most free. So it's like a traffic conductor that sits between the app, like your app, and your clients, and that figures out which road you should send your request to, so that your app is like the fastest and it's not very slow. So that's what we're doing today. And so I'm gonna build here some methods. So we're gonna say add connection and remove connection. And we're just gonna do one at a time. Di that. And it's gonna be very simple. What we're gonna do is s.stats.connections ++. And with this one we do the opposite. Right? Okay, so we built that route, and so the actual like load balancer has to, not this, main.go package. So the actual handler right here has to update those. It has to update those like numbers, the number of connections that the server is handling at the time. So right here, when we send the request, right, we want to update that number. So we send the request, and then we wait for it. So we client.do, and what we can do here is we get the server, add connection. What is next server? It's an int. Oh, okay. So we do lv.servers, the next server, and then we add a connection. Okay, so just to understand what you said so far, so your servers have a status endpoint that sends metrics to your load balancer, and it uses that to redirect traffic, right? How frequent does the load balancer ask for status information? Yeah, so that's exactly how it works. And it asks for it every 20 seconds. That's what I mean, I should probably like add some sort of customization to that, but right now it's just 20 seconds. So if I go like check health, I have a coroutine, like a go routine, that sets a ticker, and every 20 seconds it goes and checks the health of the server, of all of your servers actually. So every 20 seconds it asks, how are you alive? It asks the server, are you alive? Are you still up? And it also asks, how busy are you at the moment? And it tells you like around like 10%, around 20%. And depending on that information, it saves it so that it's able to track, to send your request to the server that's the least busy. So that's the scheduler algorithm. So right here, lb.servers next server add connection. And then once we receive the response, we close that connection. Does that make sense? I'm just thinking if like there's gonna be some deadlock here. I mean, technically for like very small numbers, it doesn't matter, because you're gonna receive your response almost immediately. The least connection, like the connection amount is good for like when you have lots of connections open at the same time, where your server is doing like some complicated operation. It takes a lot of time. Like for example, let's say you're prompting an AI and you have to wait for that AI to process it and return the response. Then you want to keep your connections are going to go up. And the 5 seconds you said before, well, the 5 seconds is actually to like time out the request. So here on like load balancer, we go back to check health. The 5 seconds right here is if I send a request for like the status of a server, I wait 5 seconds before I determine that server is dead. It's no longer healthy. Which probably wouldn't be good for medicine if you like declared a patient dead after 5 seconds, but in my use case it works, and we're just gonna say it does. So what I was worried about here about adding and removing connections was like I don't know how this works in the backend when you do a request and then it waits for it. Like, is this like a does the handler stop right there? Maybe it does. Maybe I add the connection here, and I don't know if this is like there's a deadlock right there where it like waits until you get the request and then it executes the rest of the code. I assume so. Yeah. Okay, so from what I remember, this io.readAll. So when you're returning an HTTP request, if it's like for example a video that's very long, it sends it in chunked encoding. So what that means is it sends parts of your video at the time because it can't send it all at the same time. And so that's why when you're making a request, it's asynchronous, and like the response is the body that you read is asynchronous, because you have to wait to receive the video, the whole video, and it's gonna send it to you in parts. It's not gonna send it to you instantly at the same time. So this io.readAll, it should be blocking until you receive the whole answer for the request. So I think you can wait until you've read all, and then you can remove the connection right here, and that should track the connections accurately. I don't know how we would test that later. I could like figure out a way to like create like fake traffic that's like very big, or like make some like very expensive operation in the server and see if it tracks it properly. We'll test that in a second, but for now we'll try to see if this works. If it doesn't work, what I'm gonna do is I'm gonna add this like logic for like the counting of the connections to the actual server itself and not the load balancer, but we'll see. Okay, so we're keeping track of the connections now, and so now what I would like to do is go back to the algorithms, and I'm gonna check one thing. If LAN servers turn, yeah. So one of the things that I notice here is you return the next server even if it's unhealthy. So should the scheduler handle that? Like if it's unhealthy, return the next one, or should the load balancer, when you receive the next server, it should check like, oh, this server's not healthy, give me the one after that, give me the one after that. I think it doesn't matter either way. And now that I've built the logic like this, I think it's better to do it in the load balancer itself, so I don't have to rewrite the same logic to all my schedulers. So that's what we're gonna do. Let's go back here to the load balancer. And so when we get the next server, while next server dot healthy, not healthy. Next server is an int, right? While lb dot servers next server healthy equals false. What is the problem here? LB expected found LB. How do while loops work in Go? This is probably like a very basic question, but I don't do Go for, oh, they don't have a while loop, that's why it's just a for. For LB servers, yeah. For LB servers, the next server healthy equals false. We just get the next server. And then I think I also have to copy this code over. Actually, let me put that up here. And put that down here. And declare not use next server. There we go. Let me just reassign it. So while the server we've selected currently isn't healthy, we just keep selecting the next server, because we can't send requests to servers that are unhealthy at the moment. And now that I think about this healthy part, I wonder if, I know the check health puts them as unhealthy if they do not respond. But what if after it's unhealthy, it becomes healthy again? Does it update that? Let's check. So here on status check, we get the status, and we do it for every server. Yeah, so it should. If a server becomes unhealthy at some point, I'm not, okay. I don't like this lighting. I think I'm probably gonna start streaming at other times because I just become like Jesus Christ with this lighting that I get. So if it becomes unhealthy at some point, it like sets it as unhealthy, and then on the next check 20 seconds later, let's say it becomes healthy again, it should update it back. So I think that's good. And right here we have like the add connection, remove connection, and so let's go, and we've checked that the server is healthy already. So this should only exit once the server is actually healthy, so that we can actually use that server. Okay, perfect. Oh, another reason why we needed the mutex that I didn't explain is if your server does the health routine at the same time that it's checking if the actual server is healthy, you want the load balancer to wait for it to update the healthiness of the server before checking the value, because you could like be in the case where you like check the value, the server is not healthy, and then like half a second later it updates it to actually be healthy. So that's why you need a mutex there, for there not to be a race condition on the reads and the writes. So add connection, remove connection, that's good. We have healthy servers. Okay, so now we can go to our actual like algorithm implementation. And here I didn't show the round robin, but it's very, very simple. So in a round robin, we store the current server and we have a mutex. And this mutex is for the same reason. Because the round robin algorithm keeps track, or the scheduler keeps track of the current server, and so if you're serving multiple requests at the same time, you're putting the current server as the next server, and you could have like 2 requests do that at the same time, and you're gonna have a race condition there. So that's why you want a mutex to be able to handle that logic. New round robin is like the constructor, and then the next locks it. And so the current server, when you do the construction, it starts at -1 because you have 0 servers, and -1 indicates that like none of them is the current server at the moment. When you try to get the next, if there is no servers, if the length of the servers is 0, then you make your current server -1, the selection of the current server -1, and then you return an error because you can't select the next server because there are no servers to select from. Otherwise, just pick the next one and make sure to do modulo to the length of the server so that you're cycling, so that when you get to the end of the array of servers, you go back to the beginning. And then you return this. One thing I really like about Go is the way they handle errors. Because errors in Go are a value, and so like in JavaScript and in Python, they're like blocking, where like if you have an error, your whole app stops. Whereas in Go, the way they handle it is if you have an error in your function, you return that error as a value, but you don't like your app doesn't just like automatically fail and like crash. You return that error to the caller, and then the caller can figure out what it wants to do with that error. So sometimes with an error, you don't want the app to crash because you want your app to like be like resilient. You want to do something with that error, or sometimes the error isn't even important. Like you can still do like most of your operations properly without like worrying about that error. So that's why I think it's really nice of how like Go handles the errors as values, and it returns them as values so that the caller can figure out what to do with those errors. So this is what we're doing here. We're just like returning an error if the server list is empty, and we're saying like, oh, we have no servers to pick from. We cannot select the next server. With weighted round robin, very similar. This is pretty much the same. There's this repeat. So repeat, what it does is, since you add weights to your servers, so like let's say server 1, it has a weight of 5, server 2 has a weight of 1, and server 3 has a weight of 1. You want to serve 5 requests for every 1 request here and 1 request here. So repeat keeps track of how many times you should send a request to that same server. So here we lock the mutex. If we don't have any servers to pick from, we return that the server list is empty. We do the same error as before. Then we go if r.repeat is bigger than 0. r.repeat less than or equal to 1. So right here what we're doing is when we're picking the next server, we put in repeat the amount of ways, the weight, so the amount of ways that we should repeat connections to that same server. And so if when you call the next, the repeat is not 0, you return that same server again because you want to serve another request to it. But if that repeat number is 0, then you just select the next server, update the repeat value, and then keep moving on, right? So for an example here, let's say, like I mentioned, like server 1 has a repeat of, let me just turn off my Super Maven. Super Maven toggle. Okay. So let's say our server 1 has a weight of 5, our server 2 has a weight of 3, our server 3 has a weight of 2. right? So on the next, the first time it check, we have those 3 servers. The first time you call next one, I'm back and I'm so confused. That's fair. I am covering a lot of stuff at the same at this point. But yeah, we're at weighted round robin. If you have any questions, just let me know and I'll cover them. Because I'm trying to be I'm trying to work on this, but I'm also trying to be educational while I do it. So if you have any questions, just let me know. So the first time we call next, it's gonna retrieve the first server because we've just started. So it retrieves the first server. So per server is gonna be equal to 1, and then repeat equals to 5, right? Then the next time we call next, cur server is still gonna be equal to 1, but repeat is gonna be equal to 4. Because we want to repeat the same server 5 times before we move on to the next one. And you're gonna do that like 4 more times. And once repeat reaches 0, so like next I think like 6, cur server is gonna become 2, and repeat will become 3, because that's the repeat for server 2. So it moves on to the next server and it updates the repeat. And so the next 3 iterations, you're gonna serve the same server 2. One of the problems I see here is that if your server becomes unhealthy on one of the repetitions, you're gonna have to call next a lot of times. Which might be fine. Depends on the weight that you put on your server. It might make the app slow. So we might want to add like some sort of logic here that if the server is unhealthy, just move on to the next one. So let's do that. So if r.repeat is bigger than 0, or I think it's servers, what is it? Servers.r_curserver .healthy equals false. Ooh, equal and. Okay, so yeah. So right here we're gonna do and. Let's say equals true. I mean, you could technically just leave it as yeah, maybe just yeah. So if our repeat value is still bigger than 0 and our server is healthy, then repeat. If our server is unhealthy, move on to the next one. And I'm actually going to switch these to dt that, and then here repeat. Yeah, so first check if it's healthy, and then check the repeat value. If the repeat value is not 0, then repeat it, as long as it's healthy. So that should deal with that, because otherwise your load balancer is going to keep calling next until it finds like a healthy server, and that might be happening for a while. Like if your weight is very big, if you say you have like a weight of like 10 to the 9, it's going to take a lot of time to do that process. So it's better to like just check if it's healthy, and if it's not healthy, just move on to the next one. Yeah. That should like make it a little bit faster. There's still some inefficiencies there, but it should make it faster overall. Now, okay, so that's weighted round robin done. Now we want to do resource based. So I'm gonna create a new file, resource based.go, and let's actually copy a lot of the boilerplate from here. Okay. I might have to create the file again. Resource-based.go. There we go. So we copy some of the logic from there, and then we're gonna need. So we can do 2 things. So we could have like a heap that stores the servers, like a min heap that stores the servers based on the utilization of each server, or we can just sort the array every time. And I think sorting the array every time is better, because if in your min heap, like you just take the minimum element, that number might have been updated from the last time you used it. So that's why you want to check the server list, sort it, and then pick the least resource one. You want to like do the sorting again, so you check if there's been any updates. Because if you have all of your servers in a main heap, I mean, I guess you could put them in the main heap and then pull the least element or whatever, but like that's the same as just sorting the array every time. So the main heap wouldn't actually help us here in case the values have been updated in between calls. So weighted round robin, it's gonna be actually resource based. Yeah. We're gonna keep track of the current server, that's the same. Actually, we don't need to keep track of the current server because we're not doing it in a round robin way. Do we need to keep track of anything? No, I think we just need the next. And then based on the resources that the current server is using, you like sort it and then pick. So we don't actually need these. We'll use a constructor, why not? New resource based. And return weighted rated round robin, so it's gonna be return oh, we actually, okay, so we do need this, but it's just gonna be an empty struct. Return resource based, and this can just be empty. Cannot use, okay, here's resource based. Is redeclared in this block. Yeah, it should be new resource based. Okay, and wait round robin next servers. Yep, we don't need to lock because we don't have a mutex anymore. This should stay the same, so if we don't have any servers to pick from, then we return an error. And here we're gonna have different logic. DT. Okay. Now I don't know how to sort an array in Go, which I should probably know, but I don't think I've ever done it. Sort an array in Go. Use slices. Slices.sort. Okay. Or we create a custom function. Use the legacy sort package. Okay. So let's just do that. So we're gonna import slices. Right? And here we're gonna have the logic. So I want to map our servers to only have the index of the server and the CPU utilization, because that's all the information we need. Because we need to return the index of the server that's gonna be next, and we're gonna use the resource utilization to sort the array. Now I'm kind of wondering how like that slices.sort works for objects. Okay, let's say array map in Go. You cannot simply direct a map data structure or the mapping operation. The map data structure, the map operation, it doesn't exist. You can use a for loop. Okay. And how does slices.sort work? It says slices sort work in Go for an array of arrays. Or like a slice of slices. Trying to do. Okay, so it sorts based on the first element, so that's just, I mean, what it probably should do. Yeah, so that's just like the expected behavior. Okay, good. So we're gonna do an array of arrays actually. And so let's create a type for like the server information that we need. So server info. Do we need this? No, maybe let's not use a type. I mean, it probably is better, but I don't wanna. Okay, so it's just gonna be an array of ints. How do you do that? Server info. It should be initialized empty. Wait, do I have? Yeah, I have an LSP. Okay. Okay. How to create an array of arrays and go. Okay. And what's our... I want to see... So servers... let's say 0 dot stats dot CPU usage is a float 64. Okay. So float 64 should be one of the values, and then the index should be an int. So that's our array. That's where we're gonna store the information. It's gonna be an array in this format. So server info right here, we're gonna create an array like that. Can you create an array that has different types inside? Oh yeah. Okay. No, because arrays have the same type. This is Python thinking. So maybe we do need, I mean, I could store it as a float the index, but maybe we do need a data structure. But then my question here is, how does it work for a slice of types? For like a slice with a custom type. Custom type struct. Use slices.sort func to provide a custom comparison logic instead of boolean less function used in Okay. I mean, let's just, maybe it's just that in here, sort func. Sconfunc example. Slices.sortfunc return string.compare. Oh, okay, so you're returning, yeah, okay. Right. So it just sorts it with your custom sort function at the same time. Okay. So let's create a type for it, like we were gonna do before. So this is gonna be server info. And so it's gonna have a float 64. And the float 64 is gonna be the CPU usage. And then it's also gonna have index, which is gonna be int. And so then we're gonna create a slice. How do you create a slice? How to create a slice in Go. Okay, gotcha. So we're gonna create a slice of server info. And I should actually update this. What should we call? Like server stats. that isn't really more informative, but whatever. So we declare an empty one. I think that's fine. And then we're gonna map all of the values in our servers to this server stats array. So for server in, I think it's like a server in servers, right? What's it? Expected boolean array found assignment. I'm forgetting everything. How to iterate or slice? Oh, range, right. This is so basic. I haven't done Go in so long. Sorry. For server and range servers, right? And it returns the index too, which is good. So for I server and range servers, then server stats dot, can you append to it? Invalid type. Why? There we go. Server stats dot append. Oh, very nice. Go standard live is too minimal. I know, right? Server stats append. So we're gonna append basically a slice of like, no, a server info where CPU usage is gonna be server dot stats dot CPU usage, and then the index. Imagine doing DSA and Go. I actually don't think it would be that bad. I mean, I do it in C++, but you do have the standard library there. I don't know what the packages are for stacks and queues and all that sort of stuff. I should try it out. Have you, Sean, have you ever done Advent of Code in like Christmas time? It's gonna be I. What are you doing right now? Okay, so what I'm doing right now is basically, so every time you call the scheduler for the resource based, I have to create an array with the CPU utilization, that's this float64, and the index of the server. And so then I'm gonna sort that array by the CPU utilization, and then I'm gonna return the index of the one with the least CPU utilization. That's what I'm doing. So I'm mapping the servers to like a simpler data structure that I can sort quicker. Yeah, it's all good, bro. Crack that you are Google searching and learning it the right way. Yeah. Okay, so index I. Actually, maybe I should turn the Super Maven back on. It should help me with like the syntax. Okay, so we map our servers to this server stats thing. And now that we've mapped it, we're gonna sort it. And I can delete this. So we're gonna sort, yeah, exactly. Sort that slice. Is that how it works? No, because it's not sort that slice. This is the, see, this is why you should be careful when you use AI. This is returning like an outdated package. The newest way to do it is slices.sort. And we're actually using sort func because we're using a custom function. And so it's the actual like slice and then the function that I'm using. Okay, and then do that. And yeah, I think this works. Does it returns a bool? Or is it a negative? Sort func sorts a slice. Should return a negative number. So no, this is not the way you do it. Yeah, Advent of Code is cool. I do it in JS. See, I would love to do Advent of Code in Go. And I think it would be good just to learn the standard library. So return server.stats. So this is not the proper way because this is returning a bool, and this is not what the sort function is expecting. It's expecting an integer that is negative when it's less, and it's positive when it's more, and 0 when it doesn't matter. Can you use a heap? Okay, so I did cover this before. So I can't use a heap because in between calls, the servers might change. The resource utilization for each server might change. So if I store the information in a heap, yes, it's very fast retrieval, but then I'm not having the most up-to-date information in there. And so if every time I run this function, I have to update the heap, it's the same as me just sorting the array every time. I realized that I was behind on your stream and my comments are super delayed. Yeah, I was wondering if like if I had like delay, like the stream was getting more delayed. Okay, I'm glad it's not on my side. But yeah, what I was saying regarding the heap, it's since the value for the CPU utilization is changing, then you don't want to store that in a heap because in between calls for this next function, the values might change. So you want to like sort it every time. And if you're like updating your heap every time is the same as if you just use an array and sort it. So that's why I'm just using an array and sorting it instead. So here we're not returning this. This is wrong. So what we're doing is if, yeah, return, if it's equal, return 0, sure. If it's bigger, return 1, sure. And return -1 otherwise, sure. Yeah, that's what I was gonna write. So we sort the function, and now, so we're gonna create like a picked server. We're gonna initial, actually we don't, yeah, we're gonna create var picked server. It's gonna be an int. And then for while, okay, actually we're gonna initialize it to 0. Var, just pick server is gonna be not this, it's gonna be 0. Or, yeah, actually the index, this is right. No, this is not right. This is not the way I want to do it. So we're gonna start at 0, and then while server stats, pick server CPU usage, nope, this is not what I care about. Oh, the healthiness, so I need to add that to my, so here I need to add healthy bool, and when I map it right here, we're gonna add healthy equals server.healthy. And this is uppercase, right? And so here, if server says the pick server the healthy equals false, so while it is false, we're just gonna pick the next server. And then we can return here server stat, yeah, server says the pick server index. Why is this in call to slices does not satisfy E? Let's see why. Does not satisfy E. Because it's not int, it's actually server info. Let me see the implementation they had here. You have A and B, which are both strings. Yeah, so we don't need to actually do this. So this is going to be S1 and S2. And here, we're going to do S1, S2, S1, S2. If S1 is bigger than S2, return 1? No, that's wrong. It's if S2 is bigger than 1. Right? So you want, when A is less than B, return a positive number. When, okay. A negative number where A is less than B. Oh, okay. Yeah. Okay, so if A is bigger than B, you return a positive number. So this is correct. If A is bigger than B, you return 1. In other words, you return -1. Okay. So yeah, our assert function is good now. And that should be good logic. Hopefully. And so we don't need a mutex in this case because we're not keeping track of the state. Like we could have done that with the heap, but like I mentioned, it's like you want to update the values every time you call next. So there's no point in like storing it in a heap. Even though it would probably be better for performance, it just doesn't work for this use case. Okay, I'm gonna actually just copy this whole thing, and then we're gonna create the least connections. So we have resourcebase.go, leastconnections.go. And it's going to be almost exactly the same as this. We're going to change resource-based to... I'm going to read the source code and try to understand everything. Yeah. If you want, I can push in a second. Or actually, no, maybe just wait until the end of the stream. I don't want to leave it like half-baked. So least connection struct. Oh, okay, so it's CW actually. Least connection struct. Least connection struct. I did CAW again. There we go. Now I can actually do that, which was only 3 changes, so it wasn't that big of a deal. So you kept the least connection struct, and here we're gonna, instead of keep track of CPU usage, we're gonna keep track of connections, and it's gonna be an int. And this is server info, it's the same. Redeclared in this block. See details. Let me see. Resourcebase.go. Oh, because this is the same package, so I can't use the same name. Okay, we'll just like this, call this connection server info. And on the previous one, the resource based. One second. In the resource base, we're gonna call this server info is just resource server info. Actually, let me rename. Go back. Resource server info. There we go. And now we go to these connections. Okay. Your question. By the way, how do you parse the stats? Like, how does the stats struct look like from the servers? Like, do you parse them as text, or does it send in numbers, or do you have your own custom payload? So when you send, right here, when you go, if I go to server, not this, the actual like CMD server. On the status, what it does is I have a function to get the CPU utilization. This returns a float. Which is the percentage of CPU utilization. So it's a number from 0 to 1, a float from 0 to 1. And then it returns that in the HTTP request. It returns that in the HTTP request. And then when you receive it on the load balancer, so if you like here you see like you get the CPU utilization, and then write the status line from an appendf CPU usage. Yeah, so right here, this is what you append in your payload. This is your body. You append the CPU usage right there, and then you send it over. And then when the actual load balancer receives it, here, not here, on the other one right here, when you receive, like right here, CPU usage, when you receive it right, where is it? Oh, okay. When you receive it right here, you receive the body. I have a JSON decoder that takes the body and puts that into like it puts that into this data structure, the status data structure. It's just basically like a custom object I created, like server.stats. And then we return those stats and we update them on the servers, if that makes sense. So that's why we have to on the server implementation right here. That's why we add this like JSON CPU usage, so that when you run that JSON.decode function, it knows that it should fill this struct with like from the object that you receive from the HTTP request. It should fill the struct with the CPU usage key, basically. So yeah, I get it in general. Like I just get it for like from like the status. I return in the request the CPU utilization. Let's go back to these connections right here. So connection server info. God, yeah, makes sense. Then I have another question. The load balancer has like some array of like server addresses, right? So when the server responds back to a load balancer, it responds back to the client. Yeah, exactly. So here on load balancer, on my handler, so like this is the server implementation, right? So I keep track of the URL of the server. So where should I send the request to? And so when I get the next server from the scheduler, I get the URL, and that's where I send the request to, basically. And once I receive them back, so like here after I do client.do and I receive the response, I send that response back to the client that originally requested. That's how that works. Here I write the body with the response that I got from the server. So like here, like this body right here is what I'm returning when I write the body for like the original response. So it's like a reverse proxy, right? So here, if you could like a load balancer, like when I first created it, it's just a reverse proxy. Like you have your load balancer right here, your client right here, and your server right here. Do that for the server. It sends the request. This sends it right here. It returns it. It returns it. Yeah, no problem. These connections. Okay. Resource server info. This should be connection server info. So everything that says resource server info, connection server info. And then here it's not the CPU usage, it's the connections. Right? And we're sorting based on the amount of connections. We want to pick the one with the least. And here when we're mapping, we're going to say connections. It's going to be server.stats.connections. Okay, let's go up to down and make sure everything's okay. So if we have no servers, we return an error. Otherwise, we create this server stats object. We map our server information to just put in this, like the healthiness, the connections, and the index of that specific server. Then we sort based on connections. So we want to have the one with the least connections first. We pick the server, the first server, unless it's not healthy. Otherwise, we pick the next one. And then we return the index of that pick server. So it's pretty much the same logic, but just with connections right there. Okay. So let's do some like testing. I think we can do. How did I used to test this? I think what I used to do was just here on load balancer, I just run this. It creates the containers, and I should log for each server. I should log like the amount of connections or CPU usage and make sure it's doing it properly. The thing, okay. Maybe I can do like some expensive operation so that it... Okay, let me think a little bit. I'm thinking about how I can test this. Because right now with like 3 containers, 3 servers, it's gonna be able to serve the app really fast. Like if that's not a lot of like different servers. But I could try. So I can try 2 things. I can just create like a for loop here to create like 100 different containers. Or I could go back into the server implementation, and when you receive a request, it just does some like really expensive computation there, so that it takes a while, and the CPU utilization, like you can have like multiple connections at the same time. Or I could do both. So let's go back to the server implementation. And so here on our handler, instead of just returning 200, how do you do timeouts? I did like a tick. What's the equivalent of what is it? The timeout in JavaScript? JavaScript timeout. Set timeout. Okay. Set timeout equivalent in Go. Time.after func. Oh, time.sleep. But this is on a Go routine. What if I want to be blocking? You can manually rapid sleep. Is this handle function a Go routine? Handler. I think so. No, actually no. I think it just manages on different threads, but the actual like handler is not a Go routine. So I think I can just do this. Yeah, let's do that. Okay, so right here on like any sort of response that's not status, what we're gonna do is before we even send a response back, we're gonna like set a timer. Why is this formatted so weirdly? You know what? Maybe this will fix it. No. And then right here, just like that. And so I'm gonna put here executing. Oh, this is actually gonna be in the server itself. I can check the logs, I guess. Executing expensive calculation. And right here, when we set a timer, what does this say? It's never used. We can just do that. Right. Oh. No new variables to the left side. Sure. So here, let's say it's 10 seconds instead. And then once it's done, we just print finished expensive calculation, and we respond with 200. And let's actually make this, is 10 enough? Let's make it 30 seconds. Okay. So we updated our server implementation. Now I need to like run the Docker file, like the Docker build function again. And then we'll run the server. So let me see my load balancer right here. So we create three containers. They're all gonna do expensive calculations. Okay. Sure. And then, okay, so here on make_lb, we're gonna have to update that function actually. Right here. on MakeLB, so I have here like if you put RR when you make it round robin, if you put WRR, so we're gonna do another case. If you put least connections, then least connections. And if you put, nope, this is resource-based RB. And then make random balance, no. New resource-based. Why don't these exist? New resource-based. Undefined. So right now, what does exist? New least connections. Why? For why? New round robin. Nope. New resource based. Did I do anything different? Let me actually do a V split. Round robin. No. Maybe it's just like a go cleanup thing. Ooh, I have an error here though. Wait around. Oh. So this is resource based. Let me check the other one, these connections. Yeah, I have the same problem. Resource based. Does that fix what I had? New least connections. Cannot use that. Does not implement scheduler. Missing method next. I beg your pardon? Least connections. It does. It totally does. This is fine though? Okay, maybe it's just like an LSP restart kind of thing. Yeah, there we go. Nope, never mind. Oh. Right. There we go. I'm an idiot. Okay. So we've done those. We go back. I can actually close this V split. There we go. So make LB, we're gonna make for testing, we're gonna make a resource-based one. Or no, let's do at least connections. Right. We create 3 containers, and that's it. So now, I need to some sort of way to like check the logs of like the how it's sorting the servers and such. So we're gonna go to algorithm, and we're doing these connections. So let's do that. And so here I want to print out the array and how it's sorting it and everything. Can you just print an array, or do I have to like server stats? Import. Yeah. Actually, I also want to print here the servers. Okay. And another thing I want to do, and I'm gonna create another session here so I'm able to like run personal go, because here I'm gonna have to run what is it, build container. Ow. Oh, Docker build. Okay, we're gonna run Docker build .sh. So this is like a shell script. This is a shell script I have that builds the container. That's just all it does. And I'll show the script in a second. Okay. So we have docker build.sh. Yeah, so it's just this command, like sudo docker build whatever. I just didn't want to remember this at all because it's very long and I really don't care. So I made a bash script for it, and same with the other one. Here on docker run, it was the same thing. Even though I don't need to use this shell script anymore because I can run my containers from Go, and I already do it from Go, so I don't need a shell script for it anymore. But before I used to run them manually through like the shell script, so I used to use this. And this is just basically like mapping the 6767 port to 6767 in the machine, and then it's adding this as a parameter so the machine knows to actually create the server in port server 6767, and you know. Okay. So I've created the container, so now I should be able to just go run. Actually, let me cd into load balancer, and then we're gonna do go run cmd load balancer main.go. I need to do sudo sudo go run cmd load balancer main.go. There you go. So instantiated, Docker client, server started, health check completed. So it logs here like when it's doing the health checks. So it does one like now. It takes like 3 seconds, and then it's gonna do it again in 20. So if you want, we can. I mean, no, it'll just show eventually. But now I just want to send a bunch of requests to it, and so it's serving at 420.69. Let's do this. So localhost 420.69, and I'm just gonna copy that and paste and paste. Why is it returning so fast? It shouldn't, because it should be doing the computation. Yeah, nice. And this doesn't actually print out the server, so that doesn't really help me at anything. Okay, let's go back. And then, so I don't need this pretty much. Okay. Let me think. The server implementation, right? Command server main.go. See, I thought it would like block the thing here and then execute this code, but apparently it's like a Go routine that does this. So maybe what I need to do is just put all this code inside there. Basically. What is your opinion on test-driven development? Okay. I think it has its uses. There's sometimes when, because of the problem you're designing, you should like write your code around your tests. For example, when I was doing my HTTP server implementation, it was very important for me to write the test first because like it gives you an idea of how you should write your code and the functionality around it. And HTTP servers, they have a very particular way in which they should work. However, for some others, it just kind of like slows you down and you want to like sort of like start up on the ground running. So maybe you don't want to do test-driven development for like 90% of use cases is what I think. And I personally, I am the type of like, I don't write a lot of tests, which is why like I'm trying for like this project specifically, I want to write tests for it and make sure like it's well tested. It's something I need to get better at. but it's sometimes hard to like test web applications. Like you can do unit tests for your functions and whatnot, but like then for like how they're actually working, and like how interacting with a browser, like building tests for that is harder. So maybe that's why I haven't got into it, but I want to learn how to do it. So like tests are important, but maybe I don't know about test-driven development because I feel like it kind of slows you down, and you want to be like hitting the ground up and running. Um, okay, so this should work. I just need to run the Docker build the thing again. Okay, and now we go to a load balancer again, and then we do sudo go run. And we're gonna instantiate a bunch of these. So reload, that isn't working. Exit status, end of file on 6767. Ah, I see. Is there a way to like have like a blocking? Yeah. So here what's happening, I'm pretty sure it's like it's executing this, then it's like finishing the function and not actually returning anything. Is there a way to do this blocking though? Like is there a way to like wait for it to finish? Um Set, okay, let me just chat with Gemini, why not? Is there a way for me for like this function to be blocking that is stop the current function execution and wait for the timeout before proceeding? Timeout sleep. Okay, fair enough. So I did this for nothing. It's gonna be time dot sleep. Does that return anything? Probably not. Time dot sleep that. Then we're gonna do that, do that. So executing expensive calculation and then finish expensive calculation. Perfect. Do the same thing again. Docker build. Failed to build, did not complete successfully. Syntax error expected at the end of statement in HTTP server main.go. Okay. Oh. What is this in here for? Try it again. Nice. Now we go to load balancer, and then we do sudo go run. Error response for daemon. Failed to set up networking driver, failed programming external endpoint. I don't know what this means. Port is already allocated. Oh, sudo docker ps. Okay. I understand it now. How to kill all active containers. Docker. Yeah, just kill it. Sudo. See if that works. And then here I also need to add another sudo. There we go. And now we run. So it's working properly. Now we go back to this window, we open it here, we open it here, we open it here. We're just gonna open a bunch of these, and if you see it's loading because it's doing the very expensive calculation of 30 seconds that we set. And I want to see, we have 3 servers, so if I create a bunch of these, so I have 1, 2, 3, 4, 5, 6, 7, 8, so that should be 3 connections on 1 and 2, and 2 connections on 3. If I go here, okay, we can actually, so this is the number of connections. So we can see it updating here to 1. But these numbers don't add up to me. Okay, but see here, it returned from the expensive calculation. Didn't send any data. Why? It refused to connect. Huh. So it's not handling some of the requests that I'm sending. Like it did these first 3, and then it didn't handle the rest of them. Yeah, because we had 2 here, 2 connections at the same time. Okay, let me try that again. Sudo docker ps just in case. Up 2 minutes, so we're gonna kill all those again. Technically, it should gracefully terminate it whenever I'm finishing running this program, but it's not doing it. I don't know why. Sometimes it just like it finishes in a wrong order. Okay. I should probably just close this before it starts doing a bunch of requests. Nope. So it does that. That's working right now. Okay, we have these 3, and let's send 1 more. Let's send 1 more, and let's send 1 more. What happens? So right now it's only doing 1. Oh, is it because of the health check? Because if you see right here, and I should be using this logging method instead. If you see right here, like it did the first one, then it started while it was starting the health check, and then it like the other ones are like coming in, and see, something is happening. Error write TCP broken pipe. The connection was close, but the sender was still trying to write data. Huh. See, what this makes me think is, so right now for this project, I'm using my HTTP server implementation, like the custom one, to like set up the servers, and it doesn't seem to be working for like a lot of like not even a lot, just like for a lot of requests is what I mean. What if I run just 1 server and I try to send multiple requests to it? See if that's the problem. Let's do that. Or I could try to like send the request to like the server directly. So here on the load balancer, it's going. There's one that's called 6767. So let's just try sending a bunch of requests to that and see how it handles them, and we'll go from there. I don't know if it also might be a problem with the way I wrote the handler with the 30-second thing. Let's see. Actually, let's open this instead. Okay, so instead, this time, we're gonna send a request to localhost 6767. And right here, let's run the load balancer. Let's kill the Docker containers first. Run the load balancer. So it should have created the containers. And now if I send a request here, and I send another request here, and I send another request here, and send another request here, and another one here, and another one here. Does it break? And for that, check logs of Docker container live. Docker logs -f in the name of the container. So let's check. cd whoop, nope, cd whoop, sudo docker ps. They're still up and running. The first one returned, the second one returned, the third one so it's working. So it's a problem with my, oh, okay. See, 6767 stopped, it broke. Can I get the logs from it? Valid memory address or pointer to reference. What is happening? Okay, let me just... actually, it's that docker run. So it started the server on port 6767. And now let's follow the logs. Yep. Sudo docker log, what is it? Sudo docker logs -f. Let's first do the PS. 21 seconds ago. Grab that, and then sudo docker logs -f. There we go. So it started there. And now let's send a bunch of requests. There, 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 there. Executing specific. So I only see one of these logs, which kind of worries me because it should be doing multiple at the same time. Yeah, see, why is it doing them like so slow? I mean, it is doing them at the same time. I guess that's fine. Finish there. You know what? Maybe another thing I'm thinking is like maybe like this is too many requests to handle at the same time for like that small, like a small Docker container. Because I don't know how much memory it's allotted at the same time. And like if that's a problem where it like overflows, because we got an overflow message earlier, like right here, segment the invalid memory address. So I don't know if like if the container like overflowed the memory. Okay, so it did all of them. Couldn't do this one. I just received that request. It started the expensive calculation. Okay. So it's iffy. That's the whole thing. It's just iffy, and I don't know if that's because of my HTTP server implementation, or because the Docker container is just too small and it can't handle the traffic. Sometimes it's able to. I could try changing, like, instead of using my custom like HTTP server implementation, to just using the Go, like the main library one, which I don't think would be the worst idea. I just kind of wanted to use what I had already built. I'm getting like very weird errors. Okay, let's try sending a bunch of requests again, see what happens. Okay, reload that, send 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 that. Okay, so 10 requests. See, another thing that's actually good that I want to do maybe in the future, also it's like part of like this like big library that I'm building, is if you see here, we're sending the same request over and over. One good thing to build here for the server would be a cache. And what a cache does is basically it saves like the request that you've sent to server. It saves previous answers. And so if you request the same information, it doesn't have to actually go calculate it. It just returns the answer from the cache. So building a cache in Go might be nice to like add on to this whole like library of like system architecture shit. Broken pipe. This might be a Chrome issue. Oh, you know why? Like maybe like Chrome is just like timing out because it's like, okay, you've taken like more than X amount of seconds to like send me back your request. Maybe like the remember the thing we have on our servers where it's like after 5 seconds it just becomes unhealthy. Maybe Chrome has some like logic there set up so that like if it's waiting around a long time, it just shows you this and it breaks the connection. And so then I would be receiving this like broken pipe. It tries to write to the TCP connection, but Chrome already like closed it. So let's like write less seconds. Instead of 30 seconds, let's do less. Okay, on our server here on, nope, not that. On the server here. Nope, not this either. CMD HTTP server main.go. Oh yeah, it is actually here. We go back to the handler. Very a little expensive. So let's change this to 5. And also, I wanna. It's called log, the package, right? I think log.println. Log.println. Use that instead of FMT, so I can see the times. Okay. Let me see if I'm using any other FMT. Receive the request. Let's make this log instead. Oop. FMT. I need to write that. FMT. Instantiate the Docker container. server stats. Let's change this to log. Import log. Then do that. FMT. Yeah, I think the rest is fine. We're gonna have to build our container again. Let's finish that, and then Docker build. Why did my font change? Did it change? Oh no, it's just a zoom, I guess. This looks weird. Okay. Let's run the container again. So now that it's 5 seconds instead, we just go like this, like this, like this, like this, like this, like this. Yeah. Yeah, I think just 30 seconds is too much. Like, in what case do you think a server would take 30 seconds? I mean, I guess from like LLMs, if you're generating an image or whatever, it can take more. But in that case, you're not like using the browser to generate an image. You're like the servers, like you're doing that internally through like JavaScript or whatever, so you can actually be more resilient for it taking more time. We're gonna say that's the case. Yeah. What is it? Is it F5 for refreshing? You know what? I'll just click it again. See, I think this is also another problem. Like, if before you're able to return like an answer, the connection is broken, it shouldn't break your server. It should just say like, oh, yeah, I just wasn't able to like actually return it, but that's fine. Let's go change that. Where would that be? Package server, maybe? Write error serve listen. It should be somewhere that it says like fatal. Log.fatal. This is the load balancer. So it's in any TCP listener. Actually, let me see. Error write TCP. Okay. Net.listen. This is UDP sender. Because log.fatal is the one that like kills your program, right? Print followed by os.exit, yeah. So if, well, I think the error is right here. This is the handler for, actually no, this is like I'm not using this HTTP server here. Actually let me see. CMD HTTP server. Right here on my handler, do I do a log.fatal? This is for the status, so I'm not getting an error there. That's fine. Else. See, okay, let's change this here. To instead of being log.fatal, which exits the program, to be log.println. Because error write TCP, yeah. When we write the headers to connection, let's just do also like print line here. And we're writing the status line. We're writing the status line, do we write it to the connection? No, we just like create the structure. So I think this is an error from the actual like server implementation, so you should kill the program here. But when you're writing the headers, yeah, you actually like have a writer and you write those to the connection. So this one you shouldn't kill it if like you're not able to write it for whatever reason. Just print the error, and same with the body. And I'm gonna do the same thing here just in case. Okay, let's Docker build. And Docker run. And we do this thing again. Okay, so it's able to do all of them. Nice. And now, okay, finish expensive calculation. It's still logging for whatever reason. Okay. So now if I reload this and I don't wait for me to receive a response and I close the connection with Chrome, it should print the error, but it shouldn't exit. There. So it executes the expensive calculation. I closed the TCP connection with Chrome. Finish expensive. Okay, maybe not. Let me do that. Okay, we're gonna do localhost 6767, and instead of waiting, I'm just gonna cancel it. Shouldn't there be an error? Or maybe I'll just close the tab. I don't know. Okay, do that. Close the tab. See? Okay. So it printed out that there's a broken pipe, but it didn't kill the whole program. So that's good. That is good. It's because we didn't kill. So like the problem I was having, because I think somebody just came into the stream. I have this server implementation that I wrote, and so the problem I was having was that whenever like I make a request to it, and it's doing some expensive calculation that takes a lot of seconds, and then the client that requested the thing closes the connection before I'm actually able to respond. It used to just error out and kill the whole server. Now I just log the error and I don't kill the whole server. So that's good. So let's go back. So like this, it just prints the error write TCP broken pipe, which is good. Now let's go back. And instead of running a single server, let's run the, let me do sudo docker ps. We're gonna, is this the thing where I killed them? No. Is it not? I guess not. Sudo docker kill. So we'll kill those containers. Epic Wozniak based. And now we're gonna run the load balancer. Bro, my brain is so cooked. I'm gonna head to bed now. I'm gonna look at the source code later. Yeah, it's all good. Thanks for coming, Sean. I really appreciate it. This is, I think, the most amount of like engagement I've had, and it's been very fun to have somebody to talk to. So thanks for coming along. I'm probably not gonna be here for a lot longer. I don't think I'm gonna get time to write the test today. So I'll probably do that next week on another stream where I like dedicated only to writing tests. But I think I'm happy with what I've done so far. I did the resource base, I did the least connections, so I'll push that and then probably end stream pretty soon. I'm just gonna see if I figure this out. But thanks for coming, Sean. I appreciate it. So CD into load balancer and then go run CMD load balancer a minute ago. Sudo go run. Okay, so it instantiates all of them. And now it shouldn't die whenever I do all of those things. So here, localhost. The stream, honestly, bro, keep going, thanks. For 2069. And do that, 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 do that. Okay, so now we go here, it doesn't die automatically. But these are all zeros though. -1? Okay, there's a problem there. You can't have -1 connections. How? See ya, Sean. How? I'm very confused. Bouncer. I do the mutex. It has to be some sort of race condition. Does it? But I have the mutex though. Client.do new request. So you lock the mutex, defer the unlock, and then update the connections. Okay, what happens? What happens? Okay, maybe it's helpful to draw this out. Okay. Server 1, right? Server 2. No, it's actually just the same server. So it goes to handle connection 1. And So let's think about the race conditions and how they happen. So this is at 0. And NC2 is they're doing it at the same time. They're coming in at the same time. If there's no mutex, they see the 0 and go to update it to 1, right? And what happens is that even though there's 2 connections, they only updated it to 1. So that might generate the -1, because then when they go to close the connection, when you return the thing here, and let's say they execute it in the correct order, they both do -1, and so this goes to -1. So there's a problem there. So how do we handle this? I thought the mutex would have already handled it, and I don't know if that's actually the problem here. I need to keep track of the logs. Ooh, okay, see here, 6767 died. Why did it die? What happened? Okay, let's do this. We'll try it again and keep track of the logs at the same time. Let's see if we find any errors. Yep. Let's first kill all the containers. They're all killed. Okay, perfect. This is not what I was using. Where's the other? Right here. Okay. Let's do maybe 6 at the same time, and then instantiate the server. Okay. And now we go boop, 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 boop. -1. Ooh. What if? Okay. I have a crazy idea here. What if on our algorithm, resource-based, when we do this, where we... Actually, let's go to see at least connections, because that's what we're working off of. When we do this, right, and we append this information right here, and then we sort. No, that wouldn't make sense. I'm just wondering if this is passed by value or passed by reference. Because if it's passed by reference, but this is not being modified, the index, the healthiness, those are not being modified. But I am sorting the slice. But if I sort the slides, that shouldn't change the arrangement of the servers themselves. I think it might be a race condition. Let's see our logic here. Or maybe you're not supposed to do it with a mutex. Maybe you're supposed to use like an atomic integer, and mutex don't work here, and my knowledge of concurrency just kind of sucks. That could be another thing, and that's why it's reaching the race condition. Because right here we're we initialize the mutex though, right? Like create server. Server. Like register right here. Do that, and then load balancer that made that go. Create a new server. Does this mutex, like when it does the default constructor and whatnot, it should generate a different mutex every time, right? Default constructor of a mutex. Default constructor of a mutex in Go. Mutex does not need an initialization. Okay, so that's not the problem. The zero value for a mutex is an unlocked mutex. Okay, so that's not the problem. Unlock. Maybe you're not supposed to use. I could test Claude. In Go, if I have a server and I have a structure keeping track of the amount of connections that the server is currently handling, and I add a method to update the amount of connections as seen below. Is a mutex the right like concurrency device to use? And then let's copy this. Oh, let's copy that. Atomic.in32. Doing a single integer increment. Decrement is a textbook used for atomics. Locks the entire struct, telling any other Go routine trying to read or write any field. Sync that atomic operations are at a CPU level instruction. No lock contation, no Go routine suspension. Oh. Okay. Let's do that. Let's try an atomic int. Oh. Atomic.in32. Connections.add one. So set healthy should stay the same, and here would be s dot stats dot connections dot add one. Why do we need this? It said it technically should work, but maybe we'll just try this and see if that's here. So we add -1, and then we do a thing here for connections. That returns an int32, and it return s.stats.connections.load. Yes, it. And so we need to update our load balancer implementation right here. Handler. Add connection. Add connection, remove connection. Those should be working with the new implementation now. But on our actual algorithm for connections, server that sets the connections. There we go. So we use the actual function instead. Let's try that. Okay, Claude, just minimize. Run the load balancer. Okay, and now we do that. Now -1, and it's handling them pretty fast. Okay. Okay. Oh, broken pipe. But this shouldn't exit though. Oh, maybe that's my load balancer. I don't think I updated that. Log.fatal. See, status line is fine, but then here we're gonna do log the print line instead. There you go. Docker sudo docker ps. And now let's kill all those. This is not where you kill it apparently. There we go. Run this. Okay. And now let's do this. Okay, no -1s. So the atomic seems to have worked. Okay, never mind. How are you calling him more times than you add connections? How is that possible? Maybe I need some help from Gemini. Let's see. You're running it on your home directory. Oh, okay. Yeah, don't do that. CD personal go. Gemini. Yeah, trust folder go. Okay. What I wanted to ask was, right now, for my least connections scheduler algorithm, the amount of connections stored in like the amount of connections for some servers is reaching -1. I'm unsure if this is because of a race condition, since I am using an atomic int for the connections. I just don't know what else it could be. Could I be calling remove connection more times that than I am calling add connection? Or why do you think it can be? Kinda hungry. Okay, if I don't figure this out by like 9, I'll just end stream, push whatever I have, and figure it out next time. Yeah. That I add a connection, never close it, but in that case, it would be towards the other side, not towards -1. Check held routine overwrites the entire stats struct, potentially resetting the local connection. Ooh, okay. Only a CPU user CPU and check health and using a defer and the handlers to remove this, which check remove connection is called. I don't know what this has to do with anything. You're just rewriting my code just because you feel like it. What the hell? Yeah, you're just rewriting my code because you feel like it, because it's not the way you want it. Okay, no, you know what? No. Okay, well, if that's the problem, let's go check it out. Load balancer. Nope, not this. Oh my god. I suck. Check health. Oh. Yeah, I'm overwriting it. So r dot status. So we don't want to update the CPU. Okay. R dot stats dot CPU usage equals that. Return status check. Ah, okay, so this is a problem because you don't get it from the server. So maybe I should create like a different. Okay. Like I should create like a status response that gets the least connections. And then stats is something different. Yeah, like I have stats here. This is stats for that, that's fine. But then I have like a stats response. Type, actually, just paste that. Stats response struct. And so yeah, that's what I'm gonna receive. And then so whenever I'm using server.stats, it actually doesn't return a server.stats, it returns a stats response, right? Nope. Stats response. And this is gonna be stats response, and we're gonna put it into there with the decoder. Yeah. And when you do the status check, and you get the status right here, which is a stats response, then you actually update the server. Why is server R? Whatever. Oh, response probably. That doesn't make any sense. You actually update the object without overwriting the other things. Yeah. Cool. Okay. Okay, close Gemini. Thanks, Gemini. But don't override my fucking code. Sudo docker ps, no containers, perfect. Do that. Okay. So now we go here and we go that. No -1 so far. Still going. It's just maybe the locks take a while. Yeah. Okay. Maybe let's create more of these. Like let's do like an insane amount. Um, this is 2 on each. I'm hoping like it has more. It should have more than 2 connections open unless I'm like not clicking fast enough for whatever reason. Two connections. Okay, but there's no -1s, so that is good. How did this fucking Gemini figure it out so easily? So these are all the responses. Is there a 3 in any of them? Frick. Okay. No. Can you not search Rand palette? Oh. Search. Ooh, okay. And we're gonna look up 3. Three true. No? We have 2 true. Okay, but it's handling multiple connections at the same time. Maybe it's just not printing them. You know what? I'm happy that it's not I'm not getting -1 anymore. So I figured that out. It wasn't a race condition. It was that it was when I was doing status, I was overwriting the status package, or like the status data structure. So it seems to be working. We should try the other one. Not resource. We should try the resource-based one. See what that returns. Let's try that before I end the stream. I'm gonna do that and that's it. Okay, let's end this, and then we go to a load balancer. CMD load balancer main.go. Let's create, instead of an LC, we create a resource based, right? These connections resource based. And then we run the balancer again. Actually, one thing I need to update is the algorithm so it prints out the resource based. I wanna see the CPU usage. So here, relation to format print line server stats, and then doop doop doop. And now we run. I run, I run, I run. Move me closer to that. Okay. I've done that, and now we do this. Is it increasing? One two nine nine eight, 12998. Oh, okay, so here it increased. for server 2. So they are update. I mean, the thing is, it only updates it every 30 seconds. So these numbers might vary every 20 seconds. So the numbers might vary greatly in between. But you can't be running a status check like every time you make a request. I mean, you can, but that would be like if you have a lot of servers. Maybe just run it more frequently. Yeah, maybe you run it more frequently instead of every 20 seconds. Because the server load, it's gonna matter what it is for like a couple seconds that's gonna take for it to do the request. In this case, it's 5 or 10 or whatever I set it to. And then it's gonna go back to 0, right? But there's gonna be some fluctuation in those 10 seconds that we need to care about. Like if it's 30 seconds, then doing it every 20 seconds, I think it's fine. No, because you could add like a bunch of connections in between. And like do a bunch of requests in between. So either we run a status check on every single call to the scheduler, or, which means we send, no, yeah, on every request we send X n amount of, okay, let me draw this out. Every request we get would call next, which in turn would call the status check, which in turn would send a status request to 1, 2, 3 machines, or like n machines. 1, 2, n machines, right? So every request would be O of n, whereas right now every request is just O of 1. I mean, actually, like O of like I mean, it doesn't matter in terms of this, because what matters is like if you do more requests, you have to wait more time. Because requests are asynchronous and you have to actually wait seconds, even though like so you have to have, like, let's say this takes 1 second, you have to wait n seconds for it to pick the next server. So I think that's not the solution I want. I would rather the load balancer do a status check more frequently, because I think it's a relatively okay. So there's 2 ways you can take it here. First, if you think that you're gonna receive more requests, more requests than the amount that the more requests. It depends. So it's a balance between the number of requests you get per second and the timeout between status checks. Right? So if let's say you do a timeout, a status check every 5 seconds, but you only get a request every 5 minutes, then you're gonna do a lot of these, but you're not gonna be doing a lot of these. So like you're gonna be updating the CPU usage without getting any requests. So there's kind of no point. Why am I unfocused? Hello? Okay. You're gonna be making a lot of status checks without there actually being any requests coming through for like you to actually care about the status checks. Is that okay? I think so. I think it's a matter of like how you design it, and that's why when you're making the load balancer with like, actually when you're making the load balancer, I should be asking how often do you want to do the status checks. That should be something that I should ask the user. Thanks, Alexa. And that's a trade-off that they're gonna have to consider. Like if I'm doing status checks very often, but my traffic's not very often, then I'm gonna be doing like pointless status checks. But if I have very frequent traffic, I might want to be doing it every 5 seconds instead of 20. So let's do that. Okay, that's gonna be the last thing I'm gonna do. I'm gonna implement like the user passing the amount of seconds that it should do a status check-in. sudo docker ps. Okay, perfect. So let's go back here, and when we do make lb, nope, we're not there. Make lb, we receive the algo, and then what do we want to call this? Status check timeout? Status check frequency? Check frequency. And that's gonna be an int amount of seconds. And we actually store that here. Status check frequency int. Make server scheduler and status check frequency and scheduler. Yeah. And when we do our status check here, or like here, time.second times lb.status check frequency. Or maybe, okay, actually, you know what? Yeah, we don't give it in seconds. Just do this, and then, oh, I then meant to do that. And then here, status check frequency is actually a time.duration. So if I go here, that works. We update that time.duration when we receive it here. Time.duration. And now when we create our load balancer right here, we say make load balancer. We're gonna do it every 5 seconds. 5 times time.second. Now it should do it every 5 seconds. Let's try that out. Perfect. So it runs one health check. Runs another health check. So it's running it pretty frequently. It does take a while to actually do that, but it's fine. Now that we're doing those more frequently, let's test this out. It's gonna be a lot of logs, now that I think about it. See, this value is updated pretty frequently. And it's actually picking the one... So it's 0, it's... Is it always 0? Like, I'm hoping it's not... Yeah, okay, here. 1 is less low than this, so it's updating. Cool! Okay, so that seems to be working. Now you can pass it a time. And 5 seconds does seem better because it updates it more frequently. Maybe our expensive computation can be higher or whatever, but this works. Perfect. And I think it is better. I think it is better than running a status check on every request, because that would be very expensive. A status check on every request, if I was seeing here the status check, it takes like 3 seconds. And if that's being blocking, like if you have to wait for that for the scheduler to actually make a decision, then every request is going to take 3 seconds or more. So that's going to slow down the app a lot. So we can just use those cached values of the CPU usage and do it like just more frequently, so we have like more data, and let the user actually decide how often do they want to do the status checks. Okay, awesome. Let's finish that, and we're gonna. So I wanted to write tests on the stream. I'm not gonna be able to. I'll write them next week. So next week I think I'm gonna do something pretty similar. I'm maybe not gonna have like a Hacker News segment, and instead gonna like do another one of these. I'll think about it, or actually I might get somebody to come interview live. That would be really cool, but I have to figure out who I'm gonna call. I have a few ideas. But it would be really nice to do one of those live instead of like the Hacker News segment. I could do the Hacker News segment like every 2 weeks if there's news, or like whenever there's news, relevant news. But maybe I can interview someone next week. That'd be cool. Okay, perfect. Let me just push all this code. cd and then git add period git status git commit. So we added the following. So add lease connections and resource based scheduling. Also let the user specify the frequency of the status checks. Did we do anything else? We also updated like some general code, but like I'm not gonna. Those are the main features that we added. All of this code, all of this was coded on the console.logs 2. Git push. Okay, so that's gonna be it for me. I'll announce like streams for next week on over the weekend probably, and it's probably gonna be similar to this week. It's gonna be like some sort of lead code, some sort of project building, and the third segment I'll wait to see what happens. But thank you all very much for joining. I appreciated all the engagement I had today and like being able to chat to people. And I will see you guys on the next one.